Last week I could hear everything, and I
I'm
could
sorry?
see you, and I could hear everything. It's
Yes,
just
so how was
it
it?
was on safe driving mode,
Oh,
so
yes?
it didn't let me speak.
Oh, I see. Okay,
So yeah,
right.
but the signal was great. I lost signal. That chiming that you would hear was when I would lose signal, like I would go under an overpass,
Oh, I
and
see.
then I would lose signal. But it
Yes.
was trying me back in.
But you're driving
Yes.
and watching this?
No, well, I was listening.
Oh, okay,
I was
okay,
listening.
okay, good, good. All right. Let's see, Mariana. Let's see this. Oh, Eric. Okay. Okay. Hello, Eric. Good morning. Okay, we can see some notes that you have there. So your camera is working. You can close the camera if you wish. I don't know if you can hear me or us, but I heard you're chiming in. So check your, that would be the microphone on your computer, if it has a microphone aside from the speaker. Now, if you can hear me but cannot talk to us, maybe you can send me a little chat to let me know that you can hear, or just call somebody. I think you have folks' numbers. Oh, okay, I can see now the top of your head. Okay, there, we can hear you now. All right, heard your laughter. So welcome, and we'll get started. I'm gonna just minimize the tile here. Dear Lord, we come before your presence this morning, thanking you for your many blessings, for the gift of life, and for having us here once again. We ask the guidance of your Holy Spirit so that we may discern your will in our lives. And we pray very especially for all students at this time and their learning process here at St. Thomas and throughout the whole world, that you may guide us always with your light and your truth. In the name of Christ our Lord. Amen. All right, so we keep going from one controversial topic to another here because that's the nature of bioethics. And part of that, why do you think these topics are so controversial? We've been focusing on beginning of life for now, but at some point we're going to shift gears into end of life. And well, what do you think with advancement of medical? Okay, Eric, if you want to mute your microphone. Okay.
Okay.
And that way I don't have to mute mine in case when you want to talk or say anything, just enable your microphone, all right? Otherwise we hear the background, whatever background noise is happening. Okay. So let's see. Yeah. Chat. Okay. Thank you. Yes, because technology keeps advancing, right? I mean, there's a link here between medicine and technology for sure. In fact, medical technology is one of the fastest growing fields in the world. And there's a lot of finances involved in that, so it can drive the economy. And if there is economy, there's also going to be politics involved and so forth, because it makes, it's the oil that greases the wheel, right, of finances. So there's certainly techniques that are pushing the edge, if you will. Stuff that was science fiction a few years ago is becoming a reality today in the lab. And therefore, in bioethics, we are forever asking the question, yes, it can be done. Now, should it be done or should it not be done? And to whom? You know, to humans, to animals, or to the environment. So we're forever asking that question of should it be done or not? Okay, and that's why these topics continue to be controversial. And what I try to do in bioethics then is present several principles like arguments of from nature, all right? The argument from nature, what is natural, and then also arguments of logical consistency, right? if we defend born humans and then we say that the unborn is also a human being, then we should be logically consistent in defending and protecting the unborn human being also, and so forth. So before I get into the actual topic, I want to talk briefly about Friday, because we have no class, I'm away. However, you will have a lecture, okay? It may not be as long, it may be a little shorter, but I'll record it beforehand and send it to you by YouTube. I'll send you the link in YouTube so you can watch it and give me a summary of that. And the reason for that is that on Monday, a week from today, is Memorial Day, right? So there's no class and no lecture. So I'm not gonna sneak in a lecture, you know, on YouTube. But I do need Friday's lecture because we have about a dozen topics to cover overall, all right? And we're short on time, or limited on the number of lectures. Okay, so moving forward then, we're going to look at the whole environment of assistive reproductive technologies, and within that, focusing on in vitro fertilization, and then what to do with the spare human embryos or the frozen human embryos that result from this industry. So the first distinction we have to make here is, I put assistive in quotations because it's not, we will make a difference, a distinction between assisting or substituting procreation, all right? And so the first two words actually can be called to question whether it's assistive or whether it's actually substituting reproduction. And even reproduction as such, as humans, truly animals reproduce because that's the only thing they can do. In other words, for animals, we know that the intercourse, let's say we're looking at mammals, is strictly for reproduction. In other words, the female will only accept the male when she's ovulating. And therefore, that is strictly reproduction. But in humans, it's not just reproduction. We know that men and women can have intercourse outside of ovulation, right? So there's something more, there's a plus that is happening there, even at the natural level, to be able to have that intercourse practically any time during the woman's cycle. And so we say that for humans, it's procreation. It's not reproduction as in animals, but it's procreation. In other words, that human activity, that engagement of the sexual intimacy is more than just the animal business of generating, you know, a new individual of the same species. There's more involved there, okay? Precisely because of this capacity of men and women to engage even outside of ovulation, which is most of the time, by the way, because if you look at it in a very narrow window of fertility, how long is the human egg mature? For how long? On average, what's the window? The narrow window of fertility has to do with the maturity of the human egg, right? Of the ovum, which is at the rupture of the follicle, ovulation, what is called ovulation. Then that egg would basically sit there in the ampulla for how long? You can give me hours or a day, 1 day, 24 hours, on average, 24 hours. What happens to the egg after that? Becomes over-ripened, begins to rot. It's over-ripened, and then it has to be discarded by the body, and that's the menstruation. So the narrow window of fertility basically is 1 day, which, by the way, in the male reproductive organs, the sperm, what is the lifespan of a sperm? It's about 1 day also, okay? But within,
didn't you say it was 5 days?
Exactly, and it's 1 day because it has very little cytoplasm and is not receiving much nutrition at the in the epididymis and the seminal vesicles where the sperm is being held. All right, but within the female tract, up to 5 days. Precisely, that's one of the characteristics of the cervical mucus. The cervical mucus is spectacular. It has many qualities. One is that whole highway issue that we talked about, but also it has nutrients for the sperm. And at the same time, it is a bactericide and a fungicide, so it is antiseptic for non-sperm agents, which don't belong there, all right? But simultaneously nutritious for the sperm to expand its lifespan fivefold, up to 5 days. So you can see that physiologically everything is being geared toward the conception, toward the fertility, the fertilization. But that happens, so we take the 24 hours plus the 5 days, all right? Well, within the 5 days, those 24 hours have to be within the 5 days. So now we have a 5-day window. And then typically we say 1 day before and after, kind of like a safety margin because of the unstable internet. Oh boy. Yeah, it's the weather. If it cuts off, just a little dot, it stops pulsing if I lose the connection. So just keep a little eye on that dot there, on that little dot. Anyway, so yeah, because remember, this is on average, right? And like many processes in nature and in the human body, it is normalized. What do I mean by normalized? It's a normal distribution. Statistically, it's like a bell curve, right? Bell-shaped curve, a Gaussian curve. Most people are at near the medium, but there will be some variations of the medium. And that can happen by age, during the years. It could also have environmental influences, many, many factors, even nutrition and mood of the person can also affect ovulation one way or another. So, but there's a normal distribution, and that's why we give on the tails, let's say 1 day before and after. So conveniently it's 1 week, 7 days. Out of the 28 days, we can say that a woman on average is fertile 25% of the time of the month, which means that the other 75%, she's infertile. For couples who are using NFP to avoid conception, then they have, that's the window for them, for their intimacy, is that other 75%. And of course, the abstinence that is needed in the 25 window of fertility, which would be reverse for the couple who is trying to become fertile, which is the argument for today, because in vitro, of course, is for couple who cannot get pregnant, right, for some reason. So you see, but in vitro, precisely because what the word implies is that it's necessarily outside of the woman's body, okay? Because the natural process is in vivo within the body of the woman, all right, specifically at the ampulla. So in vitro, as the word is saying, is a laboratory technique. It's a laboratory technique. And some of this technique can be quite sophisticated, all right? And that's why in vitro, it tends to be quite expensive, $20, $30, $40, $50,000, depending on how much quality control they're going to do on that embryo. It's a very sophisticated industry. It's also known as a boutique industry because it caters essentially to the rich, or the ones who can afford it. Typically, IVF is not included in medical plans. It's not covered by insurance. So it's selective. The population that has access to this is a small, really is a small sample of the general population of the couples who are infertile, right? Because not everyone has $20,000, $30,000, $40,000 to spend on this per attempt at implantation, without the guarantee, of course, that it's going to happen. So it's a boutique industry. All right, here is just an micrograph of one of the most sophisticated processes of in vitro, which is called intracytoplasmic sperm injection, ICSI for short, all right? And as you can see very graphically, here is the egg. You can see the zona pellucida, lightly, and even the corona radiata, the cumulus of cells, the cloud of cells called corona radiata that makes like a package, if you will, of the egg. All these are for protection they're going to be held naturally until the blastocyst stage, right, until that hatching happens. And you can see here, this is a needle. It's a glass needle. Imagine the size of this needle. What is the average diameter of a human egg? It's about 10 microns. So this is not only a photograph, this is an electron micrograph, right? And so this is extremely small. And you can see, I have my doubts now whether it's actually an electron micrograph or not. No, it's probably not, because it's a light microscope. It just happens to be in natural colors. It's not colorized. But anyway, imagine the size, the diameter of this needle. All right, if you look carefully, this is one sperm here. You can barely see maybe the head there and the tail with a little imagination going this way. All right, that's one sperm. And it is being injected inside, within the cytoplasm of the egg. Cannot tell exactly where the pronucleus of the egg is, but it's somewhere in here because, you know, the organelles are transparent, translucent to light microscope. But anyway, consider this, for example. This here is a glass pipette. You know, you've seen the glass pipettes that are used, even the plastic disposable pipettes that are used in the lab, all right? Well, this is the same concept. And here is a hole. And this glass pipette is actually a suction to hold the egg in place because this egg is slippery, right? Because of the zona and the corona radiata. So the egg is going to be slippery. Plus, it's a nutrient medium that is mimicking precisely the cervical mucus, the environment of the fallopian tube. So all this is very slippery. And to hold the egg in place so that it can be penetrated by this needle, it has to be held in place. So imagine, and you can see actually part of the corona and not so much the zona, but the corona protruding in here, right? See that? Imagine the finesse of the suction of this pipette to hold that egg in place and not actually suck it in there, all right? Imagine the controls on this machinery. In fact, these are called globally, these are called micromanipulators because they are designed to manipulate cells which are typically microscopic. Okay, and so these micromanipulators are extremely sophisticated technology, expensive, and this has to be done all in a sterile environment so that bacteria and fungi and viruses don't contaminate this procedure, right, and these cells. So imagine the rigor of technology that goes on here. And as sophisticated as this is, doesn't mean necessarily that it should be done. So certainly we can see that it can be done. It's being done right here in this photograph, all right? So technologically, yes, can be done. Now, should it be done? We need to cover a little more biology before we make the ethical analysis. So let's look at the procedure that's involved physically, mechanically, because we need the two main elements of the fertilization, the two gametes. We need egg and sperm, and we need them extracorporeally. We need them in the lab, in Petri dish or some kind of nutrient medium for the fertilization to occur. All right, so how to obtain eggs? It's a process called hyperovulation or hyperstimulation. I don't know if you're familiar with that process. Ever heard of hyperovulation? Okay, so we know that the natural process is one egg a month, one natural ovulation a month, which has its own issues with some pain, etc. Hyperovulation is to stimulate the ovaries, both ovaries, to ovulate, to mature, not one follicle, but as many as possible. And typically it's 1, 2, or 3 dozen follicles that mature simultaneously, okay? And the hormones are used. The typical one is Clomid, but there are other hormones that are used for stimulating the follicles into hyperovulation, and those ovaries actually swell, can come even to the size of a grapefruit or something like that, each one. So that is very painful and in fact dangerous, because the sexual organs, like many other organs in the body, are highly vascularized. What do I mean by highly vascularized? They have a lot of capillaries. Okay, they have a lot of capillaries because they need nutrition and to get rid of toxins and so forth for metabolism. So if these ovaries rupture, then the end result is a massive hemorrhage for the woman, and she has to be rushed to the hospital. Okay, and this is happening quite often, actually. A cousin of mine is a social worker at one of the hospitals in town, and that happens to have an in vitro clinic, very profitable for that hospital. And she's telling me, Alfred, I see women coming in with ruptured ovaries all the time. Okay, it's a very dangerous situation, and that's a risk, high risk involved there. So the end result of this process is that there will be at least a dozen or more eggs that have matured simultaneously. They need to be extracted. Obviously, they're not going to be passed through naturally through the tubes. So it's done with a needle extraction. A relatively large bore needle has to go through either transvaginally or transabdominally. The best technique and the safest, even though more, not sure actually of the risk of which one is more risky, but has to be done with sonogram. The needle has to be inserted all the way up to the ovaries so that the ovaries can be extracted, all right? Transvaginally through the vagina, through the wall of the vagina into the abdomen, or transabdominally outside through the abdominal region, the pelvic region. Okay. Yep.
You said that you're extracting the ovary, or just the egg?
The eggs,
Okay.
the individual eggs, not the ovary.
Yes.
No, that would be a sterilization. All right, so you can see this has to be guided by sonography, and it's a sophisticated, dangerous, risky. That needle is a metal object in there, sharp metal object, all right, in the abdominal region that is highly vascularized again. So it's very risky. The whole technique is extremely risky. Once those eggs are extracted, they're put into a nutrient medium that, again, mimics the cervical mucus and is kept at body temperature, not room temperature, right? Because this is done in air conditioning in a lab, but it's kept at body temperature, which is going to be Fahrenheit or 37 in centigrade, right? That's a standard body temperature, 37 degrees centigrade. So that requires also incubators and that other type of equipment to maintain that temperature evenly. In contrast to that, sperm is relatively easy to obtain. Sadly, typically it's done by masturbation, and then that sperm needs to be washed of semen and so forth, and there's some manipulation that goes there, but that's typically just centrifuging it and washing it. So you can see that sperm is relatively easy to obtain without much risk, physiological risk to the husband. The big burden is always on the woman, all right, by that ovulation technique. Now, that technician in the lab has egg and sperm, which, by the way, these can also be bought in catalogs and so forth, because this is totally commercialized now. This industry is commercialized. It's not illegal. It's very unregulated. And so there are now catalogs of sperm and egg by third parties that can be bought. And they give you practically the whole profile of the donor, whether it's a woman or a man, except essentially their name and their address, but they give you everything else. They give you the height, the age, the ethnicity, the intellectual, the IQ. One big source is women in universities, okay, young women, because those are the fresh eggs, right in the window of the early 20s, the fresh eggs. And they will pay the woman $20,000, $30,000 for hyperovulating. And it's totally commercialized. If she is has a high IQ, has high grades, she can get more for her eggs. And if she happens to be athletic, she can get even more. So really, you can see that it's artificial selection. It's selecting on the qualities of the donor. All right. If there's time, I'll tell you a few more anecdotes about that is happening throughout the U.S. in these clinics. So the actual process, the fertilization, obviously happens in a lab in some flasks that where the egg and the sperm are joined, and then that as soon as we have fertilization, so typically the eggs are all fertilized if it's going to be for implantation, for attempting implantation, right, and not for selling the eggs, then the eggs are fertilized. And so let's say hypothetically the woman ovulated a dozen eggs in that cycle. So we have a dozen eggs now, they're all fertilized because the sperm will fertilize whatever egg is there on average. Now we have a dozen embryos, right? We have a dozen zygotes who are living and growing naturally in incubation. So they're going to start the mitotic process of a mitotic cycle every 24 hours on average, just like it happens in nature. And they are incubated on an average for 3 to 5 days, more or less, until they reach the blastocyst stage. And then there is the attempted implantation. So they're mimicking what is happening in the natural body. Remember, fertilization in the ampulla, then about 5 days for a travel of that embryo to the endometrium for implantation, which will occur then on that window between 5 to 7 days, right? Okay, so mimicking that in the lab, now let's say at day 5, they have blastocysts, they have a dozen blastocysts, right? Assuming that they all survived, they have a dozen blastocysts alive. They're not going to implant all dozen, all right? Typically, they implant or they attempt, they insert 3 to 4, because on average, no one really knows exactly why, but the magic number is between 3 and 4, because on average, one actually implants. One actually takes from those 3 or 4 that are inserted into the woman's endometrium. On average, one actually implants. That's just so the success rate is between 25 to 33%, right? 1 out of 3 or 1 out of 4. What happens to the other 2 or 3 blastocysts that were inserted in the endometrium but did not implant? They're discarded. They're discarded, okay? So it's an abortion. Now, the question is it a spontaneous abortion? People would say, well, it seems like a spontaneous abortion because the body is naturally discarding those other 3. However, there's nothing natural about this procedure. Those abortions would not have happened if those embryos had not been inserted there to begin with. So no, they're not natural spontaneous abortions, they're procured abortions. And the technician knows exactly that by inserting 3 or 4, he's going to lose 2 or 3 on average, all right? So he's just playing the stats.
But if
Jody.
But what if the patient doesn't know how many is actually getting inserted into them?
Exactly. So here is
that whole process
to some detail, you know, but this whole industry, keep in mind that this whole industry is just trying to procure a baby to the couple. So sometimes the couple don't even want to know the details. Some couples want to know a lot of detail, others don't, all right? So it's kind of their choice, but they, so the industry will only tell them what they want to know. All right, and if they ask the question, then they'll tell them. But if they don't ask the question, they just continue with the process, right? And so, but by submitting to this process of in vitro fertilization, it's important for the couple to know really what they're getting into. Of course, when there's risk, yeah, the hyperovulation big time. They will explain all that because that's exposure, that's risk, which could involve a legal suit. If the woman was not told that she was at high risk and she actually has ruptured ovaries, then that could be $1 million suit easily for that clinic, all right? So the risky part they do say, but when it's risking the embryo, then that may or may not be stated. It depends on the couple. All right, but so following with the hypothetical dozen embryos that were eggs that were fertilized, dozen embryos, 4 were used, 1 implanted, the other 3 were discarded. Now we still have 8 that were not implanted. All right, what to do with those 8 embryos? Okay, those 8 embryos are now cryopreservation, which is that they are frozen. And how are they frozen? In what medium? What is used for freezing tissue in the lab? It's liquid nitrogen, all right? Now, there's nitrogen right now in the atmosphere. In fact, the air that we're breathing is mostly nitrogen. It's about 3/4 nitrogen. It's some 70-odd% of nitrogen, the air that we're breathing right now. But we're not breathing liquid nitrogen, right? Because our lungs would be crystallized instantly. We're breathing nitrogen, which is in natural state is gas. So it's N2, diatomic, just like oxygen is also in its natural state is gas. O2, we call it diatomic, 2 atoms. And what happens to this nitrogen that we're breathing in and out? How come it doesn't have an effect on us? No. It doesn't, actually. Nitrogen is inert. When it's in a gas form, it's called inert. We can breathe it in and out, and it doesn't do anything to us unless it's under high pressure. If it's under high pressure and it goes to our brain, it can cause an effect that is called nitrogen narcosis, which is equivalent to being drunk. Nitrogen narcosis. And that happens to scuba divers when down because of the pressure. The air that is breathing is under pressure, okay? But nitrogen then, you know, from the gas laws, as we compress gases, they can go into liquids, and if we continue compressing them, they can go also into solids. And that can be done by either pressure or temperature, by lowering the temperature. The point is that liquid nitrogen is extremely cold. It's about minus 170 degrees centigrade, minus 170 degrees centigrade. What is that in Fahrenheit? Almost twice. It's about almost minus 300 degrees Fahrenheit, okay? Is that cold? That is extremely cold. That is very cold, all right? And when objects go into liquid nitrogen, essentially they crystallize instantly. I was working with liquid nitrogen when I was at Purdue doing my doctorate in genetics, and we have to use thick gloves and stuff. You know, it's a dangerous substance. It has to be, you can buy liquid nitrogen. We have a liquid nitrogen tank upstairs. Dr. Plunkett uses that for his experiments. And anything you put into liquid nitrogen essentially crystallizes. You have to be careful. For example, if you get liquid nitrogen on your finger, you know, the finger will look identical, but it's crystallized. And so if you go like that, if you snap it with the other finger, it will shatter, right? It will just pulverize. I don't know if you've ever seen, there are videos online, look it up later. There's a little video there. A person is taking a rose, beautiful red rose, and dipping it in liquid nitrogen, and it comes out, and after the fumes evaporate, dissipate, there's a rose, identical, intact, red, beautiful rose, but it's crystallized. So the fellow goes like this, and it just shatters, it pulverizes, okay, to smithereens. So it's very cold, and that's precisely what cryopreservation does. So these embryos are dipped into liquid nitrogen. Now, these are the famous nitrogen tanks, or infamous nitrogen tanks, in vitro clinics in the US and throughout the world. Not a week goes by, last month, not 1 but 2 of these tanks started falling out overnight, in the middle of the night, because of the equipment that failed. One was in Ohio, in Cleveland, in a clinic in Cleveland. And it was a big to-do because they lost actually several thousand embryos, defrosted, you know, and died because the equipment failed. It's rare, but it happens. And then, astonishingly, like 1 or 2 weeks later, another lab in California, similar thing happened, totally independent, had nothing to do with each other. The same, the system failed, and they started thawing overnight, and the next morning they were mush. Okay, what do you tell those hundreds of people that went through that whole process and their embryos are now dead? Okay, so, but this is part of the techniques. It's a shotgun industry. Okay, so these embryos, before we move one step further, we need to clarify these embryos that are cryopreserved, that sometimes they're called spare embryos, okay? Why are they cryopreserved? Yes, exactly. For example, let's say that the first pregnancy took, right? In other words, the first attempted implantation, one actually implanted, and now the wife is pregnant and she's carrying that pregnancy, okay? But then, let's say, starting into the second trimester, she loses a pregnancy because she had, for some reason, she's not getting pregnant naturally, right? So there could be some issue that she has high risk for sustaining a pregnancy, whatever. So she loses a pregnancy second trimester. What does the industry do? They go back to the tanks, they pull out 4 more, right? Thaw out 4, and they still leave 4. So now there are 4 left over, right? 4 are going to be used for a second attempt, another $20, $30, $40,000, okay, because this is per attempt. So now, again, they thaw them out. Let's, when the thawing happens, also, it's never 100%. Sometimes there are losses there. So let's assume now that of the second 4, the second set of 4, 1 didn't make the thawing process, all right? So that's another loss, that's another abortion. That embryo died. There was nothing natural about that death, okay? This whole process is totally artificial. So it's another abortion there. Now they have 3, they still attempt, they insert the 3, but now 2 take, naturally 2 implant, you know, and the 1 then is aborted. But now she's got twins. So 2 implant, because they can't control that. They insert all 3 or 4 and hope that 1 takes. But 2 implant. However, she doesn't want twins. She only wants 1. All right. Well, then there's another technique that is called selective reduction. This industry is full of euphemisms. Okay, euphemism is trying to disguise a reality with some kind of massaging the wording. All right, like for example, they don't call it abortion, they call it interruption of pregnancy, all right, or termination of pregnancy. They use these euphemisms to try to avoid the strong truth. But selective reduction, what is selective reduction? Is that they will do some testing on the twins and see minimally they can detect what is their sex, for example. And of course, if they have any chromosomal abnormalities, all right? And then the woman can select if she wants to get rid of one of the twins. And that's what is called selective reduction, okay? Or it could be 2, 3, or 4, really, because if sometimes it happens that all 4 implant. Again, it's a statistical number. So selective reduction is selecting the embryo that she's going to keep and reducing or aborting the others, which again, they go into the techniques of abortion and carefully but surely take out the ones that are unwanted. See? This is all part of the industry. These are the services that they offer. And because it's not illegal, then it's their choice.
I have a question. Because you say that selective reduction could be done based on gender or...
Yeah, well, sex, because gender would be different later on. We want to maintain, well, if we have time, we're going to have a lecture actually on transgenderism, which is another explosive one. But the sex, at least based on the chromosome number, right? Or the sex chromosomes, XX or XY.
Usually, when you do, like the sex.
Yeah, sex selection.
Yeah, isn't that like around how many?
It depends. So it depends the technique they use. If they use ultrasound, they actually need to see a small penis, right? And so it would be beyond the 12th week, which is when the gonads begin differentiating into either ovaries or testes and the other organs. But they can also do earlier with either amniocentesis by pulling out. So amniocentesis is a needle that goes into the amniotic fluid. And in the amniotic fluid, there will be fetal tissue that is floating around. It's just skin that is sloughed off because we're constantly shedding layers of skin, right? In fact, we have an actual layer of dead skin that protects the rest of the skin. And so this skin is being shed all the time, and those are cells floating in the amniotic fluid. And so that's amniocentesis. They go in with a needle through the abdominal region and suck out some of the amniotic fluid that's sent to the lab for karyotyping and determining if the cells are XX or XY. And so they can determine the sex there.
It's not that they do an abortion after 3 months.
Right, it can be done early. Yeah, it can be done early, within the first 8 weeks, you know. And there's a technique that can be done even earlier, which is called chorionic villi sampling. I should write these things down for you for a moment, because the wording is technical. Let's see. The chorion is part of the placenta that is adhering into the mother's uterine wall. And I'm going to put it down here somewhere. Yeah, so selective reduction. It can be done either by sonogram, but that's later, it's after 10 weeks, or amniocentesis, right? Amniotic fluid. These are fetal cells. Embryo cells in amniotic fluid. And the other one is choriovilli sampling. Chorionic villi are hair-like structures that are part of the chorion, and they can be snipped and taken for sampling into the lab. They belong to the embryo, and therefore they have the karyotype of the embryo, right? Yes. Just briefly here, a little diagram. See, the chorion is part of the placenta. Let me see if I can augment this. Oh, the coloring is not too good. That's an old screen. This is part of the placenta, as you can see here, right? And part of that tissue is the chorion, which are hair-like structures projecting from the placenta and interacting with the mother, but they belong to the embryo proper, all right? So when there's a sampling of that, and here's a little cannula that is obtaining a sample of those cells, and then that will be sent to the lab for karyotyping, okay? This has a little higher risk than the amniotic fluid. Amniocentesis has, I think, about a globally about a 5% increased risk of causing an abortion or a miscarriage. And then the CVS, chorionic villi sampling, has a higher risk, maybe about 10%, almost it's about double, because now the plug is compromised by inserting the cannula, all right? So it could stimulate into contractions and cause a miscarriage. So it's a little higher risk of abortion also. To what purpose? So you have to consider to what purpose, right? For selective reduction, then it's very questionable. I put here social preferences because when these techniques are available and offered, we have to deal with human nature and the fact that in the general population overall, most couples want their firstborn child to be a boy or a girl. A boy. That's the social preference, okay? And that's across the board, anywhere from here to China. In fact, that caused a big challenge in China when they had this forced one-child embryo, one-child policy. Most couples were choosing boys, also because it's more expensive to maintain girls. They even have to pay a dowry to get them married and all that. They can get less work out of a woman than out of a man, etc., etc., etc. So that for decades that policy was on, and it actually skewed the Chinese population of that 50-50 percentile into a higher, significantly higher population of men, and these men now are growing, becoming young men, are looking for women which are less abundant, and there's more competition, and it causes a lot of social friction when that 50-50 balance is skewed, all right, either way. And so we have to, this manipulation is having an effect at the social level. What was the last day that amniocentesis could be performed? I think it's 8 weeks. I'm not sure. If you want to look it up, okay, for both of these techniques, look up amniocentesis and CVS, all right, because they have their limits. But it's within the first 8 weeks, and you can look them up, all right, and maybe report next time. But it's in the idea is to do it early so the abortion doesn't seem as perhaps the mother has not identified with her child yet, and so forth. But these are realities of social preference, okay? So all this favors boys and disfavors girls. Overall, what do we have with IVF? We can see that it really bypasses natural selection totally. Okay, that selective pressure of the sperm fertilizing the egg of the 100 million to 1 selective pressure against the sperm is totally obviated by a technician just washing the sperm in the lab. And typically what they look at mostly if the sperm has a tail or not, and that's the level of crude selection that they do, but it certainly doesn't match the sophisticated selective process of natural selection, which is down to the actual biochemical level, which can just not be obtained in the lab, right? So it is equivalent to artificial selection in the sense that the eggs and the sperm are being selected and manipulated, and the end result is that truly, if we're honest, a baby is being manufactured in the lab, all right? There's a manufacture of an embryo in the lab, and that's the reality. Now, we can look at in summary of the IVF techniques, and then after this, we're ready to make an evaluation, a bioethical evaluation on this, all right? It's a high risk of the women due to the hyperovulation and the egg extraction techniques. Then the typical sperm collection is also a procedure that is not part of the sexual activity as such, all right? It's a selfish act of the husband or the male man there in the clinic, which is not part of the intimacy with his wife. There are many abortions involved due to the failed implantation and also in the freezing and the thawing of embryos. Here, I want to point out, by the way, that those embryos that are cryopreserved, are they dead or alive or what? What do you think? An embryo dipped in liquid nitrogen, crystallized at minus 300 degrees Fahrenheit. They're dead? You think they're dead?
I feel like they're alive, because if they were dead, they will have no.
They're like on a pause.
Yeah. Think about it. So if they were dead, once they're thawed, we would have a thawed dead embryo who is not going to implant because the embryo is dead. Okay, and it's not that if they were dead and we thaw them out, they come back to life, because there's no resurrection here. There's no magic or mystery going on. This is a physiological, biological process of organic life. So they are certainly alive. They are alive, but they are in what we call suspended animation. They're in equivalent to a coma, suspended animation. All right, the metabolism has been slowed down so much that is practically the cells, the molecules are practically not moving. They may just have a little bit of resonance, and that's about it, but there's essentially no metabolism occurring, right? So they are in suspended animation. In fact, one time I did an experiment when I was studying biology, and about your age, my parents were living in in Panama at that time, and I was studying at FIU, my bachelor's in biology, way before thinking about the priesthood. Went to visit my parents one summer, and I had heard about cryopreservation, and I wanted to do a little experiment. So I had learned how to catch bees without getting stung, all right? And you have to be careful, but you can do this. When you come behind the bee, if the bee is at a flower or something like that, nectarizing, you can grab, as long as you grab the 4 wings together. They have 2 sets of wings, right? And you grab the 4 wings together, the bee sting cannot turn around and sting you. All right, because the bee sting can only sting forward. And so you cannot get stung. And then what you do is you take a piece of cloth, a piece of the shirt, and you put a little saliva on it, and then you move the bee across that spot, and the bee will sting, and the sting will get stuck in the cloth, because the sting of the bee is similar to a hook. It has a little barb that comes backwards. So it gets stung and gets stuck there. And then you pull the bee and the sting will come off, all right? Unfortunately, in the long run, the bee will die because it leaves behind a piece of the abdomen at the very end of the abdomen. And the bee will then get infected from there and die. But someone taught me how to do this when I was a teenager. And I took some bees for an experiment, a few bees, put them in a jar and put them in the freezer. At my parents' apartment there when I was visiting. And my mother kind of freaked out because she opened the freezer and saw a jar full of bees. But anyway, after a while, I pulled out the jar and they were frozen. And certainly it was not cryopreserved, because this is just normal freezing below water freezing, okay, so below 32 Fahrenheit or 0 centigrade, which is nowhere near cryopreservation, but they were frozen. And I pulled them out and I laid them out on the counter, and they were all curled up like this, okay, stiff, frozen. Let them there to thaw out passively. And they thawed out passively. Took maybe half an hour to an hour, and some of them started walking around. Not all, but some of them started walking around. And then after a little while, some of those started flying around. Okay, so it's not that they were dead and came back to life. They were in suspended animation, and that's cryopreservation. Okay. Now, at some point, I'm going to introduce an argument of natural rights here. All right, we have cryopreserved human embryos, and who has a right to do that? And were the embryos consulted? Obviously, they were not consulted, okay? It's high risk to the embryo because many of them don't survive either the freezing or the thawing process, and without informed consent. Anyway, at this point, because in vitro has been going on since 1979, I don't know if the name Louise Brown means anything to you. You folks are very young to remember that name, but she was the first test tube baby. That's what she was called back then, test tube baby. You can look up her name at some point and Google it. And this was, she was actually manufactured in 78 and she was born in 79. And the 2 doctors were Edwards and Steptoe. You can look those up also. They were the ones in UK that invented this technique of IVF. And she's the first one that was successful. We don't know how many trials were done. Typically 100 trials were done before they succeeded, but Louise Found eventually grew up and had children of her own, and that was the proof of principle until she didn't have any children of her own, because she had to obtain reproductive capacity and demonstrate that capacity, biologically, to prove that that in vitro fertilization would work and generate and manufacture a human being who was actually fertile. Okay, but she was the first one. Eventually, Edwards and Steptoe went on to receive the Nobel Prize in Medicine a few years ago. And yet, what has happened over these almost 40 years now is that these spare embryos continue to accumulate in the lab, in these nitrogen tanks, okay, in vitro clinics throughout the US and throughout the world. And in the United States alone, it's estimated to be maybe close to 1 million human embryos at this point are accumulated, because that case of the couple that I was narrating hypothetically started with 12 embryos, right? And she lost the first pregnancy, and then the second pregnancy took, and she had twins, and she selected one out. She still has 4 in the freezer, right? She still has this other 4 in the freezer. And so what to do with those 4? Well, that couple already has the child that they wanted, and they don't want anymore. And so they have to pay a maintenance fee for that cryopreservation, because this industry is not going to do it for free. All right, there's a cost at every step of this technique, and it may be relatively inexpensive. It may be $100 or $200 a month, or maybe $500 a year. Who knows? But over time, that starts accumulating, and a number of couples walk away, and they abandon their embryos. And so what does the clinic do with these embryos? Typically, periodically they have to clean out those tanks, because they cannot keep holding embryos, and they have more and more tanks in the lab. The space is limited, they're paying the rent, etc. And so periodically the tanks of the embryos that are abandoned are discarded. They're either discarded as medical waste, or sometimes they're just flushed down the toilet, etc. This is the reality of the industry. Now, the industry has actually found a way of making more profit, because they can donate the embryos, and I put it in quotations, donate, to what? Well, no, these are already embryos, right? To labs that are doing stem cell research, because the embryonic stem cells is the ICM. Remember the ICM dinner cell mass, right? Those are the embryonic stem cells. Those are the actual embryonic stem cells, is the ICM, all right? And so these embryos are donated to labs that are doing embryonic stem cell research for research. That research is destructive research, right? The embryos are going to be disaggregated, they're going to be killed. Doing embryonic and I put donate in quotation, because what happens? Yes, they cannot sell the embryos, because then that would be human trafficking, right? So they donate the embryos, but the lab, of course, the clinic, the in vitro clinic, is entitled to being compensated, which is not a donation, is being compensated for the expense of procuring those embryos, of cryopreserving them, the whole technique. So they can actually get to charge double for the procedure. They charge the couple for the procedure. Now they can charge the labs for at least part of the procedure, because they're donating the embryos, but they're entitled to compensation. It's just like when we do volunteer work, but the person who we're doing the volunteer work for could possibly give us compensation for gas money or things like that. You see?
And I'm pretty sure the patients don't get any of that.
Of course not. The patient just walk away with their baby,
Mhm.
that's all they want, and then they disappear.
Mhm.
Okay, yeah. So this is part of the industry. I mean, sadly, it has become commercialized, and truly, when you look at it, they're trafficking with human cells, we're trafficking with egg and sperm, they're trafficking with embryos, all right? And it's legal. It's legal because the law just cannot cover every aspect, and part of it has to do, I go back to the first lectures, that we just don't concede humanity to the human embryo, you know, the legal humanity. All right. Going for a little further, I just check. Is this the original? Okay, that's the same question. Now, there are other issues that come up because we're thinking kind of in the best case scenario of a married couple who after years of trying to have children, they cannot have children, you know, and so they go through this route of IVF. They happen to be well off and they can actually pay for the whole procedure. But these embryos are accumulating. Now, sometimes these couples divorce, and who's in charge of the embryos that are left behind? There have been already legal cases where they fight for the embryo just as they fight for the house and the car and the property and the bank account and all that. They have to split it, you know, and the embryos also are split, if you will. The woman doesn't want them, wants to implant them, but the husband doesn't want them implanted, and it's half of his DNA, and it's just a royal legal mess to try to sort that out, because who's in charge of those embryos? And at the end of the day, bottom line, for the state, for the government, for the law, they are actually property, okay? So they have to be distributed in the divorce decree, just like the other property. So that tells you the excessive manipulation. When these issues are pushed to the legal limit, they become property, all right? And they have to be distributed just like the other goods or property of a couple has to be distributed in a divorce case. Bigger picture, natural selection. It is evident that in vitro fertilization has nothing to do with nature, right? It is a manipulation of a process precisely because it's not happening naturally. Then they do it artificially. So it denies natural selection, but not only to the child, the species as a whole, because at this point, it's been estimated that there are thousands, if not tens of thousands at least, maybe, I don't know if it's even hundreds of thousands, because the industry doesn't report, but how many human beings are now the product of in vitro that are walking society today for the past 30, 40 years, all right? There are thousands upon thousands of them. Many of them don't even know that they're in vitro because their parents just haven't told them. And they don't know. And I can tell you a case that happened in the Midwest precisely when I was studying at Purdue, because it's Purdue is in West Lafayette, Indiana. It's in Indiana, which is a breadbasket state. It's in the Midwest, all right? And it's basically rural areas. These rural areas, it's very flat. You look out in the Midwest, and if you don't see corn, then you see soybean to the horizon all around you, okay? But so it's very rural, and sometimes these clinics are sparse apart. And it happened to the case. It was like the perfect bad storm for this in vitro process. It happened to be a small town where there were several couples living there, and they were friends with each other and so forth. One couple could not get pregnant. They went to the local in vitro clinic, and after the procedure, she was able to get pregnant and hold the pregnancy and have the child and so forth. But the problem was, it was his problem that his sperm was incompetent, so they ended up buying the sperm from a donor, all right, an anonymous donor on the catalog. Fine, she had her child and so forth. That's called heterologous when it's not, it's a third party. Homologous is when the cells come from the couple. Yeah, I guess we can put them here on the both, either one. It's a little more too detailed, but this is where heterologous is a donor. Gametes. Right, homologous is, let's say, spousal. Okay, understood. So heterologous is third-party IVF. Today, for many years, sperm have been frozen already. More recently, eggs have been able to be frozen because of the cytoplasm. That was an issue. They have much more cytoplasm, and it was an issue on success. Anyway, this what happened at this clinic was that this one couple got pregnant with this very potent sperm, right? And they had their child, very happy and so forth. Well, another member of the group of their friends, another couple, was also having difficulty in getting pregnant. So they had a good recommendation from this couple, went to the same clinic and got pregnant also, all right? And find out they have baby at home too. And these couples were friends together with others. And so some of the other couples have their own natural children and everything else. But of course, all these children are friends to each other. They're growing up together as friends and so forth. And as they get into the teen years and later teen years, and it actually happened, one boy fell in love with this one girl, and they ended up marrying, and they're half siblings. They came from the same sperm. And then they were wondering why their children were abnormal, okay, because they came from the same sperm donor. And this is a true story. This is a true story. Happened years ago. I wish I had saved it, but it happened. And because the sperm of this one donor, and that's what he did, and he actually had sired, hundreds of children throughout the States, because his sperm was so potent that many clinics were using that sperm. And this is the truth. And these kids didn't know.
And then that's when we found out after doing all those tests.
Yeah, and then the grandparents of now their grandchildren are having abnormal children, and they're saying, why are these children abnormal? Well, because you're half siblings. They had the same sperm. And then imagine that the trauma for these, the children to know now once they're, yes, that's not their dad. It's not their dad. They were generated that way, they were manufactured in the lab. They were allowed to marry each other and all this. The two couples actually didn't know because the donor is anonymous. The two couples didn't know it was the same donor. Okay?
The best one,
Yes.
the best chance you can.
Exactly. The most competent sperm. And I tell you, some men are professional sperm donors, and they sell. The sperm is sold and the eggs are sold. Like, for example, this industry, the vitro industry, pays women for their eggs. Okay, they pay much less for sperm, but some men just sell their sperm, and if it happens that they have very competent sperm, very vigorous sperm, then they get better price throughout the nation. This it really is trafficking what's going on, but it's not illegal. Not illegal. Okay, so this whole issue of natural selection, I think we have to take it seriously, because it may be a very small percentage of the population, but that percentage is starting to increase slowly but surely, and they're coming into the gene pool with all that background, and who knows who they are or everything else.
I think more and more, if you look back, I feel like people didn't have any problems, having kids, and nowadays couples
they're having more
are
problems.
having more difficulties. It
Yes.
might be linked to women using contraception pills or the environment. I don't know, but it just seems that it's more difficult
It is.
for a couple now to.
It is. Part of it is also that women are postponing having children to an older age, and this is part of the challenge. And I tell you quite frankly, I find a challenge in college women more than in college men, because there really is more at stake. There's more investment for a woman to get a college degree, because obviously after all the studying that you've done and all the blood, sweat, and tears of getting that degree, obviously you want to put that degree into practice and you want to develop a profession. But that may also interfere with family life and having children earlier, like in the early 20s or mid-20s, which are the best eggs, really, on average. Postpone it. Some women are even freezing their eggs until they get into the 30s and then throwing them out. But that's not going to have the best quality egg, all right? Because that process has an impact. It does have a physiological impact. So we can go back and ask the original question. Why is a couple infertile? Okay, there are physiological reasons, or there could be psychological reasons. Sometimes the intensity of wanting a child so much can actually prevent them from having children. And I don't know if you've heard of this, but I hear it all the time. A couple who could not have children for years, and they, at some point, they either did the in vitro or they adopted a baby, all right, either here in the States or they even went elsewhere to adopt, in Latin America, whatever. But the point is that now this couple has a baby at home, so they're no longer concerned about having children. 6 months later, she's pregnant. You ever heard of kids like that? It happens. It's amazing. So where was the presumed infertility? What I'm trying to say is that not always is it physiological factors, okay? Sometimes there's psychological factors that influence here too. And so at the very end, with regards to human fertility, in my opinion, the best medical advice is just leave it alone, relax about it, just don't be so intense about it, all right? Relax about it. If there's going to be some minor resistance, fine. Like, for example, unblocking tubes, fallopian tubes can be have some scar tissue, or also the male tract can have some scar tissue. Unblocking something like that, maybe some kind of light hormonal supplement, hormonal support. For example, overweight people, especially in men, can be a target for women also, can be a target for infertility. Just the fact that there's too much body mass and they will have low estrogen or low testosterone, okay? So being back in shape is a normal way of increasing fertility. Underwear, you wouldn't believe it. Remember the scrotum and the fact that sperm is delicate and sensitive to temperature? Men who wear tight underwear pushes their scrotum up against the body. That can be killing their sperm, okay? So loose shorts for men. Conversely, for women, you know what could be a cause of infertility? High heels, believe it or not. High heels, yes. Don't believe me. Google it. Yes, because you know what happens with the high heels? It actually shifts the pelvis. It shifts the pelvic axis forward, and that's precisely why it's more attractive. Quite frankly, what is more attractive about high heels is that it shifts the pelvic axis forward, all right, so that more behind shows. It's a physical effect, if you think about it. But moving, walking around for a sustained period of time daily on that shifted pelvis does affect, because it's impacting directly the pelvic area and the organs that are in the pelvic region, which are precisely the reproductive organs. It's pushing them in a position that they're not naturally used to being. So that can also be, that has already been correlated to a degree of infertility in women, all right? Again, don't believe me, Google it please, because it's amazing, the causes of infertility that are going around, all right, of contemporary lifestyle. Intense intervention like IVF and other techniques like ICSI, for example, stuff like that, I say it's out of our realm. It really, we have a natural right to natural selection. Just like we have a right to breathe in air, right? Because it's part of our functioning of our metabolism, we have a natural right to natural selection. And why should we be preventing this to individuals? Without their knowledge, without their consent, there's no way that the embryo can consent. And to the species as a whole, to the human species, all right? Because this is impacting the gene pool one way or another. End of story. Thank you once again for your patience. And okay, Eric, if you have a question or a comment, I'm going to close here, all right? Okay, so I don't see a chat or anything, so I'm going to stop recording.